All right, in Math 4, our very first lesson that we're going to learn is on solving linear equations. So this should feel like a review from Algebra 1 geometry and Algebra 2, so hopefully you can go through this a little quicker. So we're solving an equation, which means we're going to want to bring all of the variables to one side of the equation and all the constants to the opposite. So most of you are going to subtract 7 from both sides. Keep your equation balanced, leaving you with 4x equals 20. And then final step, divide both sides by 4. So x equals 5. And I know a lot of you like to do this work in your head, but I would like you to show some steps. The next question is 5 halves x equals 20, and some people view that as 5 times x divided by 2. So you could simply multiply by 2 and divide by 5, or you could multiply by the reciprocal of that fraction, which would be 2/5, which would cancel out the fraction of 5 halves. But of course we got to make sure we do this to both sides. So 2/5 times 5 halves is x, and that is, let's see, an 8. And of course, calculators are always suggested. That's my little Logan in the background, being loud. Alright, so of course we step it up a notch, and we're going to find out that in this next set of questions, yeah, Log, we have variables on both sides. So we're going to subtract, I'm going to subtract 3a from both sides, so it looks like I'm bringing the variables to the right. And at the same time, if I'm bringing the variables to the right, I'm bringing the constants to the left. So 21, yeah, equals 6a. And then last step, divide by 6 on both sides. And we're going to always want our answers as reduced fractions, so you could either math enter that on your calculator, or both of these are divisible by 3, so that would be 7 halves when I reduce that. I don't want decimals, I don't want mixed numbers, I want an improper reduced fraction. And of course you're familiar with the distributive property. We're going to multiply this constant into the parenthesis set, so that becomes a negative 12x. Don't forget to multiply all the way through, plus 4. And then same distributive property happens here. So negative 10x plus 40. Let's see, there's still a minus 14x off to the side there. So on my two sides of the equation, one thing I noticed is that on the right hand side here, I've got some like terms that I need to combine and rewrite that right hand side. So negative 10x, and then later on minus 14x is really negative 24x plus 40. It's best if you simplify each side before you start moving across the equation. So, it doesn't really matter, but I'm going to bring this time the x's to the left. So I'm going to add the 24x, so my x's combined to the left. And if I brought the x's to the left, that means the constants need to go to the right. So I'm going to subtract 4. And I notice some things canceling out. And let's see here, that ends up being 12x equals 36. And then final step, divide by 12 on both sides. And you get x equals 3, I believe. Okay. So next we step it up a bit. And we're going to solve equations that contain fractions. Now if I wasn't allowing you to use a calculator, you're going to want to use a trick. Okay, sorry, I had a little timeout there because I had some diaper problems. All right, we're back. So we're solving an equation with fractions. So the technique that we're going to be using is multiplying by the least common multiple of the denominators, or the least common denominator. And 6 and 12, there's various multiples of them that you can use, but the smallest one is a 12. So if I was to multiply everything in this equation by a 12, which is like a 12 over 1, what happens is 12 is going to contain whatever portion of the denominator is there, and since it's a multiple of it, it's going to cancel out the denominator and give you a single integer. So 12 over 1 times x is 12x. And then 12 times 5 over 6. If you want to do this in your head, it's quickest if you do the division of 6 first. So 12 being divided by 6 is a 2, and then 2 times the 5 up top is a 10. So when you multiply by a fraction, it's really a multiplication of the numerator and a division of the denominator. So you can do it in your head pretty quickly. And then back here, 12 times 2 over 12. 12 over 12 is divisible by each other, so that's a 1. 1 times 2 is 2. So now I have a very easy 1 or 2 step equation depending on how fast you work.
I want Peppa Pig. I want
2 steps.
Pig and cheese.
Oh, you want Peppa Pig, I hear you, bud. Alright, 12x equals 12, and then divide by 12 on both sides, so x equals 1. Alright, Don't worry, we got Peppa Pig turned on. So, next question. Our denominators are 4, 5, and 2, and a least common multiple of 4 and 5 is 20, and 2 is a divisor of 20, so that works. Some people just multiply 4 times 5 times 2 together, and that would have given them a 40, and what they found was a common multiple. It's not the smallest, but it's still going to work the same way. But if you were ever doing this like in your head and you couldn't use a calculator, you want to choose the smallest one as possible because no one likes to do extra work. So 20 times 3/4. So 20 divided by 4 is 5. 5 times 3x is 15x. 20 times 3/5, let's see, 20 divided by 5 is a 4. 4 times the 3 is a 12. 20 times 5 halves x. 20 divided by 2 is a 10. Times 5x is 50x. And then 20 times 1/4, 20 divided by 4 is 5. So now I have a much simpler equation that I can solve. I think this time I'm going to bring the x's to the right. Since I brought the x's to the right, this constant needs to move to the left. So let's see, that's negative 17 equals 35x. And I'm dividing by the coefficient of x, so I'm dividing by 35 on both sides. And of course, I want to leave my answer as a reduced fraction. Don't bother typing that in your calculator. And I'm thinking that is fine. 17 is prime number, so it can't reduce. And 35 doesn't have a divisor of 17. All right, so the next problem is complicated only because it also has the distributive property. So before you add additional parentheses to the problem with the LCD, let's go ahead and distribute the 3/4 times 3/5, 4/5, excuse me. And when you multiply a fraction times another fraction, you look for cross cancellation. So in this case, the 4's would cancel, and you'd end up with a 3/5 x for the first term. And then when you take the 3/4 and you multiply it by the 2, or the 2 over 1, this last part here. Again, you can think of it as cross canceling. 2 and 4 reduces to a 1 over 2. So we really have a 3 over 2. Change colors on you, sorry. All right, so now our denominators are, okay, same as the last problem. So a little boring, but an LCD is 20. So 20 multiplied to everybody. Let's see, 20 divided by 5 is 4 times 3x is 12x. 20 times 3 halves would be 20 divided by 2. 10 times 3 is 30. You can do that multiplication on your calculator. You would just simply do, 20 times 3 divided by 2, and it's going to give you the right answer. But it's nice to not have to grab a calculator every time, especially as you guys are getting ready for college. 20 times 11/4. 20 divided by 4 is 5, times 11 is 55.
What is that, Mama?
Okay, baby. Logan would like to say hello to everybody, and that he's watching Peppa Pig. All right, so adding 30 to both sides, there we go, and then final step, divide by 12. 85 is an interesting number. Does not reduce 85 over 12, so we're going to leave our answer as just that. Moving along. Solving proportions. We're going to multiply, cross multiply. I'm sure you remember this from way back in the day. It doesn't matter which diagonal you do first, but it is 6 times the quantity x plus 2 for this first diagonal that I circled. And we're going to equate that to the other diagonal, which is 4 times the quantity x minus 3. So make sure you distribute this all the way through, and that gives you a 6x plus 12 equals 4x minus 12. And I'm going to choose to bring the x's to the left, which means my constants are going to the right. And some people get worried, they think the 12's over here cancel, but they actually don't. And you get 2x equals negative 24. Divide by 2 on both sides, and you get x equals negative 12. You guys have done a ton of equation solving in your life, so just make sure you go slow enough where you don't make a goofy mistake. Now here, it almost looks like a proportion, except this weird plus 4 is stopping it from looking exactly like a proportion. So I'm going to have you subtract the 4 first. And we end up with negative 2x plus 10 over negative 5.
Mama, I need your color.
Okay. Equals 9. And if I rewrite that as 9 over 1, hopefully you can see it's exactly a proportion. Some people just say, oh, I'm going to multiply both sides by negative 5, but that's exactly what you're doing when you cross multiply. So negative 2x plus 10 times 1 is just negative 2x plus 10. And then negative 5 times 9 is negative 45. So we're going to subtract 10 from both sides. Don't lose your negatives. So negative 55. So negative 55 divided by negative 2 is now going to turn out to a positive 55 over 2. Okay, we're going to write some linear equations. That's fancy talk for take a story problem and set up an equation. And I know this seems lame to some of you because why would you need to do this exact problem in real life? You probably wouldn't. But this is setting you up for ways to actually program computers, and we'll talk more about this later. A real estate broker's base salary is $18,000 and then a 4% commission on all the sales. So her target, or his target, whoever it is, her, they want to get $55,000. So in order to achieve a total salary, whatever you want that to be, that would be the base salary plus whatever you sell times the commission rate. So her total salary that she's aiming for is $55,000. And we know that the base salary is $18,000. The sales are unknown to us, so the sale number is actually going to be the variable, and the rate is 4%, which we're going to write as a decimal, of course, which is 0.04. And then in math, you choose your favorite variable. It could be anything. I'm lame and I'll use an X. And they want you to actually solve this, so let's go ahead and solve. So subtract 18,000. Oh goodness, let's see, that's 37,000 equals 0.04x, and I'm going to steal my calculator, so I am not doing that in my head. She's got to sell $925,000. 25,000. $925,000 in sales. And she's a real estate broker, which means she's selling property and houses, so that's a logical number. Don't freak out. Okay, summer job pays $5.60 an hour, and then $8.40 for all the overtime hours. How many overtime hours are you going to work if you want to earn $287? So total pay is $287, and the regular pay is $5.60. And if we're assuming that we're going to have to work overtime, that must mean that we ended up making or earning more than $40. So the $5.60 an hour is only paid for the first 40 hours. So we're going to have to figure out that number. And then the $8.40 is going to be for all the overtime hours. So whatever that number is, I don't know, and I'm going to call it X. So first thing I'm going to do is figure out what $5.60 times 40 is. So if she works overtime for sure, she's going to get $224 right here. Alright, so you see where I'm going with this. We're going to subtract the 224 to figure out how much money in dollars she needs to make for her overtime pay. Oh, let's see, that's 63 equals 8.4x. Yeah. And if I divide by 8.4 on both sides, turns out that she's got to work 7.5 overtime hours to meet that pay. All right, moving along. An iPad was purchased for that much. So that's what they paid in the register. And there's a tax rate of 8%. So there's some subtotal, so we'll call that X. But then the person also has to be charged 8% of the subtotal for tax. And that's how the register comes up with the $464.40. So right here I have a like term of X. So 1x plus 0.08x is 1.08x. And I know some of you don't, you're not striving to program cash registers, but this is totally a use of it. So we're going to divide both sides by 1.08 and get our answer. Let's see here. 464.40. 108% paid into the register. Okay, so originally this iPad cost $430. All right, and that's our first warm-up lesson on solving equations. It gets good from here.